Hi again, and welcome to this segment of Maths Exam questions on speed, distance, and time. Question 18. A car travels at a constant speed of 20 meters per second. Work out the time it takes for the car to travel 10 km. Give your answer in minutes and seconds. You want to start by converting 10 kilometers into 10,000 meters and perform the division in accordance. Question 21. The travel graph shows Michael's journey from his home to the beach. At what time did he start his journey? From the travel graph, Michael started his journey at the place where I have marked a circle. This is at 8:10. Next, on the journey, he stopped for a rest. Find the distance he was from home when he stopped for a rest. During this time, Michael should be at a fixed distance from his home. The y-axis indicates this at 8 kilometers. Next, for how many minutes did he stop? The x-axis indicates that Michael stopped from 9:20 to 9:50, amounting to 30 minutes. Next, explain how the graph shows that Michael traveled faster before he stopped than after he stopped. The gradient of the travel graph represents the speed. This is evident that the gradient is steeper when Michael traveled before he stopped. Question 5. The distance between Prague and Vienna is 254 kilometers. The local time in Prague is the same as the local time in Vienna. A train leaves Prague at 15:20 and arrives in Vienna at 19:50 the same day. Calculate the average speed of the train. The clocks tell us that the total time of travel is 4.5 hours. The average speed is therefore 56.4 kilometers per hour. Question 24. The diagram shows information about the final 70 seconds of a car journey. Find the deceleration of the car between 60 and 70 seconds. Deceleration, like acceleration, is equal to speed over time, which equals to 2 meters per second squared. Question 24b. Find the distance traveled by the car during the 70 seconds. Distance is the product of the speed and time components. In this case, it is also the area of the trapezium, which leads us to the answer 1,300 meters. Question 1f. The average distance from Earth to Mars is 2.25 times 10 to the power 8 kilometers. A spaceship travels from Earth to Mars at an average speed of 5.8 times 10 to the power 4 kilometers per hour. Find how long in hours the journey takes. The length of journey is its distance divided by speed. Question 7. The graph shows part of a train journey between station A and C. Calculate in kilometers per hour the speed of train between station A and B. Speed is distance represented by the y-axis divided by time represented by the x-axis. Next, the train leaves station B at 14:40. For how many minutes did the train stop at station B? Looking at duration at which the graph is flat, it shows 10 minutes. Next, the train travels at a constant speed between station B and station C, arriving at 15:20. Complete the travel graph for the journey between station B and station C. The blue line on the graph is the required plot. Next, on which part of the journey was the train traveling faster? The line is steeper in the first half of the journey. Therefore, the train is traveling faster between station A and station B. Question 7b. Another train leaves station C at 12:45. It travels to station A at a constant speed of 62 km per hour without stopping at station B. Work out how long in hours and minutes this journey takes. The length in time can be calculated by dividing distance with speed. Next, write down the time this train arrives at station A. It is 15:15. Next, on the grid, show the journey of this train. The added blue line represents the journey of this train. Next, find the distance from station A when the two trains pass each other. This is where the two lines intersect. Referring to its y-axis, it indicates 60 kilometers. Question 11. Brett traveled from his home in New York to Chamonix. He left his home at 16:30 and traveled by taxi to the airport in New York. This journey took 55 minutes and had an average speed of 18 kilometers per hour. He then traveled by plane to Geneva, departing from New York at 22:15. The flight path can be taken as an arc of a circle of radius 6,400 kilometers with a sector angle of 55.5 degrees. The local time in Geneva is 6 hours ahead of the local time in New York. Brett arrived in Geneva at 11:25 the next day. To complete his journey, Brett traveled by bus from Geneva to Chamonix. This journey started at 1300 hours and took 1 hour 36 minutes. The average speed was 65 kilometers per hour. The local time in Chamonix is the same as the local time in Geneva. Find the overall average speed of Brett's journey from his home in New York to Chamonix. It is best that we start by mapping each of what is said onto the table below. To the airport, the journey took 55 minutes and was at an average speed of 18 kilometers per hour. To Geneva, we could tell the time taken based on the difference in the two clocks as well as the difference in the timings of the two local times, and its distance from the flight path that is taken as an arc of the circle of radius 6,400 kilometers with a sector angle of 55.5 degrees. And to Chamonix, the journey is said to take 1 hour 36 minutes and is at an average speed of 65 kilometers per hour. Next, we complete the distance in km column of the table for Brett's travel to the airport and to Chamonix to identify the total distance he has traveled, followed by the total duration of Brett's trip as determined by the start and end times considering the time difference. The average speed is simply the total distance divided by this total duration. Question 1. Here is part of a train timetable for a journey from London to Marseille. All times given are in local time. The local time in Marseille is 1 hour ahead of the local time in London. Work out the total journey time from London to Marseille. Give your answer in hours and minutes. One method is to offset the timing in Marseille to what it is in London and find the difference. Next, the distance from London to Ashford is 90 kilometers. The local time in London is the same as the local time in Ashford. Work out the average speed in kilometers per hour of the train between London and Ashford. Speed is distance divided by time. This comes to 150 kilometers per hour. Next, during the journey, the train takes 35 seconds to completely cross a bridge. The average speed of the train during this crossing is 90 kilometers per hour. The length of the train is 95 meters. Calculate the length in meters of this bridge. By letting x be the length of the bridge, the required distance is x plus 95. By mapping the distance over time with speed and working at this in meters and hours, we can solve for x being 780 meters. That's all for this segment. Do get into our other videos under KT Tutorial channel if you've liked this.